Hello, good morning, good afternoon, good evening, and welcome to today's webinar on best practices for scaling Selenium testing. My name is Mark Lambert, and I'll be hosting today's presentation along with my colleague, Chris Colosimo, and we'll be talking about how you can really streamline your Selenium testing process. What are the typical challenges that most organizations and most teams face, and we'll be presenting some solutions to those. Now, before we do that, let's go ahead and actually talk about just a little bit about Zoom. Make sure that you guys understand how to ask your questions. There is a Q&A box that's up and running. So if you kind of have a question as we're going through, just feel free to throw them in there. I'll be actually reviewing those when Chris is doing kind of the technical part of today's session. And then we'll come back at the end and we'll kind of recap the key questions. If you have any problems during the course of the webinar today, please go ahead and put in a message into the chat channel. We also have the Parasoft team watching there as well to help if there are any challenges. As I said, my name's Mark Lambert. I'm the VP of Products here at Parasoft, kind of sitting on overall product strategy of how we can help organizations implement continuous quality practices. And one of those key quality practices is around functional test automation. And obviously, Selenium is a key part of functional test automation in most organizations today. I'm joined by Chris Colosimo, and Chris is actually the product manager on top of the Parasoft functional test automation suite. And Chris will be going into the details of Parasoft Selenic today and talking about the best practices for Selenium and how Selenic can streamline that process for you. Now, before we get into the details of the technology and the details of Selenium, it's worthwhile taking a step back for a second and understand why we are doing testing of our web UIs and our web applications. And really, the key is that we're trying to ensure that we can deliver a reliable and consistent customer experience to our customers. And this is really very key for three primary reasons. Firstly, disruption is in absolutely every market today. Look at the situation with the transition to online shopping. That's an obvious one. Amazon established that market, but the transition to online or online taxiing systems like Uber, for example, has also disrupted the taxi industry. Airbnb disrupted hotels. But also the same kind of disruption is going on within the financial industries. So open banking or PSD2, breaking up the monopolies that the banking industry has, especially within Europe, focusing on introducing new players into the market and rapidly changing the market landscape. This is compounded by the market's demand for new functionality. The ability to deliver and get out functionality to your clients quickly is going to be key to make sure that the company can succeed in capturing the market, but also retaining the market. And that's where the delivery of a reliable customer experience is key. Because while these innovations are great, if you are impacting the core functionality, or if those innovations are not delivered in the most resilient form possible, then you're going to find that you're going to lose or you're going to churn your client base. Switching costs have never been lower. It's been easier for people to switch from one provider to the next. Certainly the disruptions from the point of view of PSD2, that's one of the goals, is to make it much easier for people to transfer their accounts and transfer their data back and forth. So it is very key that we can actually enable a reliable customer experience as part of that deployment. Now, how do we ensure that that customer experience has been validated? How do we ensure that the customer experience is reliable? Well, the obvious thing is we test, right? So we test it. We don't just test it once. We're testing it continuously. We have to do continuous validation because we're going through a very highly iterative, agile workflow. So you need infrastructure to enable that test automation. And if that infrastructure is not well maintained, you're going to have problems, because what's coming down the track is not a slow delivery. You've actually got a very fast, high-speed delivery of your functionality to market that's coming down. This is what really Agile and DevOps enables. It enables quick delivery of functionality, iterative feedback, so I can improve and hit my target more accurately. And if we don't have an infrastructure that enables that, then my delivery is going to come off the rails, and I'm going to be overtaken by my competition. You don't want to be the next headline around a poor delivery or a failed launch, or even worse, potentially leaking of customer information. Now, how we enable a scalable delivery and a scalable test automation strategy is by aligning to the testing pyramid. This is a very well understood concept within the Agile community. In essence, you start with a foundation of unit level tests, either be those unit tests for using something like a JUnit or an NUnit, or at the code level, or even being unit tests at an API level, where you're testing a programmatic API, typically a REST API, kind of things that sit behind your web applications, testing those in isolation, but then also starting to test the business logic at that API layer. Now, the key here is that that foundation of unit tests backed up by API tests gives you a really solid part of your testing pyramid and a really scalable way of moving forward with your test automation. But you still need to be able to test the UI and test the application end to end. The purpose of the testing pyramid isn't to obliterate or remove UI testing, or even not just automated UI, but also manual UI. It's to use it proportionately. Focus your efforts for UI testing, be it through automation or be it manually. Focus it so that you can get the best return on investment. Obviously, that manual testing effort is the most valuable tests. These are the ones where you can bring the human in to the process, you can get the insights, you can get deeper understanding around the usability of the application. And humans are very good at spotting these kind of non-predictable situations. Computers, however, are really good at doing repeatable tasks. So if we can focus on automating the UI tests, which are in essence boring and repetitive, we can free up our manual testing efforts to focus on the more creative part of a testing strategy. Now, all of these tests don't mean anything unless you're building on top of solid ground. And this is where I like to talk about continuous quality rather than just continuous testing. Test automation is great. You want to be able to run that continuously though, which talks about test environments and how I can make my tests run anytime, anywhere. But if I'm just testing, I'm not building quality into my application. You can't test quality in, you have to build it in. And this is where deep code analysis focused on reliability and security issues within your code base provides solid ground to build your testing strategy on top of. Now, at Parasoft, we do have a very fortunate situation that we've been in the industry a little over 30 years. We've spoken to thousands of organizations about their testing practices and their testing maturity. And what we can clearly identify is that most people still identify to some level with an inverted test pyramid, or sometimes referred to as an ice cream cone. This is typically because people understand UIs. UIs are easier to kind of exercise. They're designed to be intuitive, but they take a lot of time to execute. They're difficult to maintain from the point of view of stability. UIs are often changing very aggressively. You know, people are introducing new UI elements, changing layouts, and then any kind of test automation breaks. So while we look at the UIs as being intuitive, we really know that we have to focus our efforts if we want to be able to create a maintainable testing strategy there. Now, actually, when we talk to folks and we dig a little deeper, it's really not an ice cream cone. It's more like a martini glass. We do know that many organizations struggle with the adoption of API testing and testing at the programmatic interface that sits behind your UI is really one of the most effective ways of scaling test automation, and certainly one of the most effective ways of doing load and performance testing as well. However, there are technical barriers and technical hurdles that need to be overcome. We'll touch upon this very briefly today, but our primary conversation today is all around Selenium. And why are we talking about Selenium? Well, first of all, as we saw previously, most people are testing through the UI. That's certainly the place where many people start. So how are people testing through the UI? This data is actually from over 600 interviews at trade shows, customer interviews, webinars like this. You might have noticed we asked you some questions coming into today's webinar. And from those 600 respondents, we identified that there's over 64% of that audience are actually using Selenium as their test automation infrastructure. And really, Selenium has become the de facto standard in the industry. But it is still fraught with a lot of the same kind of problems that many people face when they come to UI testing. These range from everything from maintainability of those tests through the amount of time that the tests take to execute, because actually the higher up you are on the testing pyramid, the longer they take to execute, the more complex the test environment. So we talk about operating systems, browsers, and devices. The more difficult they are to maintain when the UI changes. I mentioned that earlier. And the harder they are to diagnose as well. As how can I actually get into understanding when those tests fail? Now, we can break this down actually into a few key challenges. So firstly, test creation. So creating of your Selenium script in the first place. We'll talk about some of the best practices there as to how we can do test creation in the most effective way possible. But it's worthwhile noting that while many people, when they're first starting with Selenium, will focus on test creation as being the challenge, once you get to the point where you're mature with your Selenium testing practice, it very quickly falls to the bottom. You start building in practices around, we'll talk about the page object model today, best practices for your team, for your organization. You're not trying to write a whole end-to-end web application. You're just writing a simple test script that happens to be in Java. So that knowledge barrier very quickly goes away and goes to the bottom of the list. What populates to the top, though, are the challenges associated with maintenance of the tests. Now, we'll talk about how you can create tests to be more maintainable from the start. We'll also talk today about different types of locators and ways of handling wait conditions. And Chris is going to show us how we can address those, how we can also get into the details of looking at test automation failures and diagnosing what's going on within the test infrastructure. So with that being said, Chris, I'm going to hand over to you and kind of show us how we can address some of these top testing challenges and obviously how Parasoft can help with Parasoft Selenic.
Wonderful. Thanks, Mark. Can you hear me okay?
Yep, I can hear you great.
All right. Hey, everybody. Thanks for joining today's webinar. So let's go ahead and jump into today's demonstration. So I'm going to be taking the role of a test automation engineer, working with Selenium tests in my IDE. Today I'm using IntelliJ. I have written a series of tests here inside of this IDE using JUnit. And I am particularly proud of these tests because I've implemented a lot of best practices in order to make these tests more reusable, more scalable, and more maintainable. The first one of those best practices is that I'm using something called the page object model. Now, in the page object model, you define the pages of your application as objects in your code. You then define element locators on those pages, as well as the methods to interact with those element locators. Those objects are then referenced inside of your code, and it makes it so that if something were to change, say a username locator, you could change it in that one-page object, and it would propagate through the rest of your test. And it's one of the best practices that you can use for making your tests scalable. These tests I have are validating some key functionality in my application. I have a banking application. I'm testing accounts, I'm testing bill pay, and I'm testing request loan. I run these tests as a part of my nightly or continuous execution. I get value from them by being able to validate the individual areas that they are testing, as well as associating them with work items in a system of record. In this case, I'm using Jira. Now, as I said, I'm quite proud of these tests, and that's why it makes it particularly frustrating for me when they break due to application change in my UI. And so I'm going to actually be going through a demonstration of that and show how we can solve that through our maintainability and through Parasoft Selenic. Parasoft Selenic is a plugin for Eclipse and IntelliJ, and it allows us to monitor the execution of Selenium tests and get some great AI-powered recommendations for that. So let me actually show you a demonstration of how that works. So I've created a configuration for this test to run, and I'm essentially running against my banking application, Parabank, that's currently deployed here at 8081. Now, what I'm going to do is I'm just going to run this test as is to validate that the current version of my test works against the current version of my application. So here comes the first test here, and we're going to validate accounts. All right, that guy looks good. Here comes the second test. We're going to run against a bill pay form in my application. Okay, looks good. And then here comes my third test. All right, so all three of my tests are successful. Against this version of the application. Now, what I've been told is that development has told me that a new version of the application is becoming available. And there are some minor changes against this new version of the application, but we know that even a minor change against an application can have a major impact on your test automation. And so I'm going to go ahead and just call open these two versions of the application. Here's version 1, and I actually have version 2 here, and I've just hosted it at a different port, port 8082. Let's go ahead and log into this. Okay, here's version 1. I'll go ahead and log into version 2. Okay. So it looks like the data is changing a little bit between these versions, but it's not immediately clear to me if there's anything else that has changed. And so what I'm going to do is I'm just going to run my current tests against the new version of the application, which is something that we do all the time. And I'm going to see if there's any major changes. The second thing that I'm going to do when I run these is I'm actually going to activate Parasoft Selenic. So Selenic is a part of the run configuration here in Eclipse. And as I said, it monitors the execution. And if there were any failures due to bad locators or wait conditions, it will provide me with some recommendations. So I'm just going to make sure that that's on. And then I'm going to run the tests. Okay. So here comes my tests against version 2 of the application. Okay. All right, so it looks like the first test was successful. Here comes the second test against the bill pay area of the application. Okay, well, it looks like maybe something might be wrong here. I'm potentially stuck either at zip code, maybe there's something with phone number. I'm not sure if my current test is going to support that. Okay, looks like I got a stack trace. All right, no problem. Here comes test number 3. Okay, well, it looks like this UI is significantly different. It looks like I have some dynamic loading content. Looks like my test is doing a, nope, it failed. Right, and so this is a place that we've all been. Now the tests are broken. I'm getting information at this point that there's something wrong with the application, and it's not immediately clear to me what I need to do to resolve that. The good news is that as those tests were executing, Parasoft Selenic was watching. So let me go ahead and open up my Selenic report here. And so what we'll see here is that Selenic has identified that there were some tests that failed. It failed due to in this case, potentially bad locator, and then a bad weight condition. You see, what's happened is that Selenic has monitored the execution of the test. And as failures were showing up due to those bad locators or bad weight conditions, it was trying to understand what was actually happening between the test code and the browser, and then providing me details back into my report so that I could understand what happened, as well as potentially seeing a screenshot of what may have happened with the application. Now, it turns out in this case that I was not able to click on phone number. And the reason that I can't click on phone number, if we were to go down into this bill pay section, is that the phone number has actually turned into a dynamic ID. This is very common in applications like Salesforce, and we see it more as forms are being dynamically constructed from code. This means that this element would be very, very difficult to click on repeatedly. The good news is that Selenic has provided me some recommendations. And so we can go ahead and look at those recommendations. Now, here's where we can see the AI at work. You see, Selenic is providing me with a series of potentially new locators that I can use. And it's also given me a series of factors to help choose the right locator in my code. These factors are weight and stability. Stability says, against different versions of this application, how successful would this version, this new locator that's being constructed, how successful would it have been? And additionally, because there's different strategies such as CSS, XPath, TextLink, class name, weight allows us, the human, to define which strategies we want to prioritize over others. Maybe I like CSS links more than I like XPaths. And through that, we come at a confidence factor. And this confidence factor allows us to make an educated decision on which locator to use. And now to make things really powerful, we can either copy this locator to our clipboard and apply it to our code, or jump immediately to the line of code in our application and update the locator right here. And this makes it much easier to make those modifications in a scalable way across different teams and across different users. This test would be successful because now it's not, it doesn't really care about the dynamic nature of that ID. But wouldn't it be cool if I was able to self-heal those tests at runtime? And so what I'm going to do is I'm actually going to revert my changes here, make the code broken again, and I'm going to turn on self-healing in my run configuration. Now, the idea behind self-healing is that as those tests are executing and Selenic is starting to see those failures potentially occur from bad locators, bad weight conditions, stale element references, so on and so forth, instead of letting the test fail, it's going to try out new locators. It's going to try to adjust the weight conditions. And then from that, provide us more educated recommendations to say, okay, the test didn't fail, and here's why. And here's what you can do to then fix your code. At the same time that I'm executing this, I'm going to go ahead and grab that HTML report and report when the execution time exceeds a specific threshold. We'll talk more about that in just a second. So now I've got self-healing on. Let's go ahead and run these tests again. Okay, this is going to happen kind of quickly. So take a look in the bottom right-hand corner. I'm going to draw your attention to when the self-healing takes place in the console. And it's going to happen right here in our bill pay test when it runs into phone number. You see it gets stuck in the bottom corner, initiates self-healing, finds a new locator, and the test proceeds forward. Great. All right, here comes that dynamic content. We're going to see kind of the same thing. It's going to come down to the loading button. We'll see it wait here for a second. It's stuck. Self-healing is going to make the test wait a little longer. Apply now becomes available, and the test moves forward. Okay, so now our report looks a little different. Here now we see that instead of having a series of tests that failed, we had tests that healed. Two tests specifically, my bill pay test and the one that clicked on the request loan. If we drill into these, we can see those same AI-powered recommendations, as well as information that indicates this was used to heal that locator. We have those same screenshots so that we can understand where that test self-healed, as well as having stack trace and test detail information so that we can feel comfortable in applying this recommendation into our code. If we look into the second test, the self-healing was actually one due to a wait condition. You see, it was waiting for that apply now button to show up, but it couldn't do it because it was taking so long for that to load. So instead it said, you know what, I'm just gonna wait. I'm gonna wait a little bit longer until that element becomes unobscured. Now, there's many ways that we could fix this, but Selenic has given us a recommendation to use a fluent wait. Now through this, what we have are much greater information about debugging and diagnosing failures that take place in our test code, as well as providing information not only about what happened when our tests were failing, but valuable information both in the report as well as in the IDE on how we can immediately fix those locators. And by combining this with something like the page object model, it makes it very easy for us to maintain and scale our Selenium testing. But there's something else that's very, very interesting in this report. And those who are keen-eyed might have noticed this execution time threshold. So I spoke about this earlier. Now, since Selenic is monitoring the execution of my Selenium tests, and it's capturing information at runtime to help with the recommendations and the self-healing, it's also capturing execution time and generating a benchmark or a baseline of the standard execution time for my tests. And you'll notice here that I actually had one that exceeded that threshold. And this is really important. If we look down here at all tests, we can see all the tests that executed, whether they passed, failed, or whether they were healed. And additionally, we can see performance benchmarking time. In this case, request loan has some kind of a performance problem. The historical average that this test takes to execute is 14.61 seconds. In this case, we're exceeding that average by a threshold that we defined during execution. Specifically, this test is taking 16% longer to execute than normal. That may be an anomaly, but that may also be the initial whispers of a performance problem. And essentially, we get this for free as we're executing the tests. We could then look and say, you know, we may want to run the request loan scenario under load to verify that something bad didn't just happen during the most recent code check-in. And it's one of those early warning triggers for our reporting process for performance. Okay, so we've got a series of tests that have executed. We have then self-healed those during the failure. We can then jump back immediately to those tests, make the change in the code, and reduce the maintenance burden of our existing Selenium test scripts. But wouldn't it be cool if we were able to make tests like this that use the page object model and these best practices from the very beginning? And so that's where the third part of our story comes in, and that is one of test creation. Now, in my application, I'm currently testing, three things. I'm testing the bill pay, the account, and the request loan functionality. But it turns out I have another UI in this new version that I need to test. And I would like to create a new test for that. So I'm just going to take a look at that real quick in the application, get a good feeling for it. We have a new area here where we have a whole new set of requirements for find transactions. Specifically, in this new version, we can find transactions by amount. And so I'd like to build a test, and I'd like to add it to that existing set of tests that I have. So that's where the Parasoft recorder comes in. And Parasoft recorder attaches into the browser and allows us to record UI actions for Parasoft Selenic in pure Selenium using the page object, which we'll show you. At the same time, if I wanted to, I could also record API tests so that I could get both of those testing types together. And it really helps build out that strategy that Mark was referring to, where we're building that solid foundation of unit and then API tests. Today, I'm just going to do the UI actions. And so I'll just start recording. Go ahead and log in to the application. I'm going to go down to my find transactions. I'll find a transaction by $100. Okay, no transactions, great. I'll go ahead and log out, and then I'll stop the recording. Okay, so here we see a little UI for Parasoft Selenic. I'm gonna go ahead and call this find transactions. And I could give it a description if I want, testing transactions for search. And I can also associate it with a requirement. So here I'm going to do a work item in my build system. In this case, I'm using Jira. So I'll go ahead and call this, I think I'm working on story 78 today. And we'll see how that embeds into the test later. I'll go ahead and download the recording, find transactions, and then I'm going to go ahead and save. Okay, now I have recorded that in my UI, and I could either have been the test automation engineer, or I could have been a manual tester who's more familiar with the UI workflows. I could then take that test artifact that was just downloaded, and I could either hand it off to a test automation engineer or use it myself. In this case, I'm going to use it myself. Now, let's say, for the sake of argument, I didn't have any Selenium tests at all to begin with. I would have the ability to come into my project and create a brand new Selenium test from recording. And so in order to do that, I could just say, let's go ahead and create a new project. And in that new project, I want to use a Selenium recording. But I already have a Selenium project. And so in this case, what I want to do is I just want to add it right here into my, into my existing test. And so I'm just going to right click and I'm going to say create Selenium test from recording. I'm going to supply it with that recording. Let's go to my recent guys here. Class bank test, test find transactions. Okay, that sounds good. We'll go ahead and say okay. All right. Now a couple of things just happened at once. The first thing that happened was that a new transactions test was added here into my existing test suite. And we can see it's actually down here at the bottom. The other thing that's happened is that brand new page objects have been created. And so if I was to open up my page objects, here's a new one called find transactions. You see it's updated those page objects and added in that information so that I'm building these tests the right way the first time. Okay, I've also got my requirement that I added in here. So what I'm going to do is I'm going to go ahead and execute this test. And we should see now 4 new scenarios. So it looks like transactions is actually going to be the first one that fires off. There we go. So my new test was successful. And then of course I am using self-healing and performance benchmarking. So I will get that advantage to all the rest of my tests that execute. Okay, here comes the self-healing again for the bill pay. I should use that recommendation and update that test so that it doesn't do that anymore. But then of course the final test here is the request loan. Okay, and there comes the wait, and we're successful. 4 brand new tests, everything was successful. We'll get those nice results from Selenic and really be able to take control of the maintenance and creation portion of our testing strategy. And so for that, I'm actually gonna hand it back to Mark to talk us through what we just did. So back to you, Mark.
Great, thank you very much, Chris. So what Chris went through here, let me see if I can get control, there we go. Actually, starting with the end. So Chris showed us how we could leverage the Parasoft recorder to create our Selenium test scripts. Those Selenium test scripts were using the page object model. And one really key thing here is that those Selenium scripts don't have what would be referred to as vendor lock. They are pure Java Selenium scripts. So there's no embedded Parasoft code that locks you into the Parasoft ecosystem. It gives you the ability to create the tests, and then they are fully portable, so you can implement them into your CI/CD process. These tests obviously are incrementally building as well. So Chris showed us that we could create a new project from scratch, but we could also add to our existing project structure. And then, as I said, those tests can go into your CI/CD process. Now, they are, as I said, fully portable, so you can just put it into your existing CI/CD pipeline and just go. Or you could actually put in the Parasoft Selenic runtime in there as well. So this is a one-line code change to your existing test script, and that will give us the ability to do self-healing. And the key thing about self-healing for me is this stops your CI process from artificially breaking. You're not actually changing the underlying test scripts, you're kind of patching them at runtime. So you're not changing the tests, but you're also not artificially breaking the build. Now, that feedback though then goes back to the tester, the person creating the test scripts, goes back into your IDE and provides you direction to say, here's, your test broke, here's some different ways of fixing it, and here's how I fixed it as part of that process. Now, the other thing that Chris showed us though was when he created those tests, you'll have noticed that there are some Java annotations embedded within that Java code. Those Java annotations are used for traceability. So you've got them right there in your files or in the Java class. But really, what's very powerful is that the results of your test automation can also be sent to Parasoft's reporting and analytics dashboard. Here, it can be combined with other test and quality data, such as code analysis, unit testing, etc., and also cross-correlated with the user stories or the test artifacts that are being managed within your Jira instance, or maybe you're using the X-Ray plugin like we use at Parasoft for test management. This gives you full visibility, so you have the ability to be able to see not only that your tests ran successfully, but how to associate those with user stories, so you can understand the impact of test failures and also understand your level of test completeness. So we kind of addressed a number of these issues. We talked about maintainability with the UI changes, wait conditions, locators. We talked about the debugging and diagnosing of the automation failures. We also touched upon that last one, which was the knowledge and skills required to create the test scripts. But we didn't talk about the amount of time that it takes to execute the tests in the first place. As I mentioned earlier, the higher you go up on the testing pyramid, the longer your tests take to execute. And this is because of the overhead of spinning up the web browser, but it's also because of the infrastructure and the dependencies that you're connected to as part of your application. So how can we actually optimize that test execution? This is where Parasoft has very unique technology, which can be, again, plugged directly into your Selenium testing practice. So here what we're going to do is we're going to focus our test execution to focus just on the parts of the application that have been changed. So we do that in 3 parts. So firstly, using Parasoft's proprietary coverage analysis, we're able to understand what parts of the application's code base were exercised by specific tests. Now, that doesn't require access to the underlying code. We can actually do this on the Java binaries of a deployed application, so WAR files and the like. Once we know what parts of the code base your tests are touching, we can then cross-correlate that with changes in that code base. Again, by analyzing the underlying code, but also analyzing the changes in the binaries themselves. We can then focus on only executing the tests that are touching or validating those code changes. This gives us the ability to optimize the time that it takes to execute your tests. It gives you the ability to focus and get quicker feedback from your CI/CD process. Because the key thing here is Chris has showed you, what, about 3 or 4 different tests there in his test scripts. You guys don't have 3 or 4 different tests. You have 3 or 4,000 tests. And getting feedback from those takes hours. If you can reduce that to minutes, you can focus your test regressions on just those pieces that are changed. Now, we actually at Parasoft provide technology for unit testing as well with our JTest product. And this JTest has the ability to do this for JUnit tests, and both in your IDE as well as part of the CI/CD process. We have our API testing technology, Parasoft SOA test, and also Parasoft Selenic enables us to do this for Selenium tests as well. So actually, Chris, do we have a few moments? Maybe we could just do a little bit of an overview of that and maybe actually show the how this works in Jenkins so we can kind of touch upon how this would integrate into the CI/CD pipeline.
Great. Yeah, let's take a second and take a look at that. So I have here hosted in one of the cloud machines a Jenkins, and I actually have a test that runs. And what it does is it will run my UI tests that I've created and the API tests that I've created. And when it runs these tests, what it does is it executes them and then goes and looks at the WAR file so that it can collect coverage to understand what each test is touching from a code perspective. And as you can see here, it is just a one-line change that you make to your application. Once I have that coverage, I can then grab that and look at it in association to the WAR file and say, okay, what does that actually cover? And what are these tests associated with? I've done that for both my UI tests and for my API tests. And then what I do every time I have a code check-in is I run my smart test execution for both UI and API tests. In this case, I then go ahead and say, all right, go ahead and look at the new WAR file. Tell me the difference between the new WAR file and the old WAR file, and then only execute the tests required to validate that change. And so the bottom line is, when I run these tests, in this case, I'm running 11. Okay, it's not a big number, but imagine if that was 11,000 tests that you were running all the time. With with test impact analysis, you only have to run a subset of those tests to validate the change. And so in this case, let's go in here and look at UI tests. And so it turns out that in this case, it's only 3 tests that I need to execute from this perspective. And then from my API test perspective, I think it's 3. And so imagine the time saving that you would get by only executing the tests that you need to execute to validate the changes. And so in a short little bit, Mark, that is test impact analysis with smart test execution. All right, Mark, you might be muted. Mark, I still can't hear you. It might just be me. Okay, so
there we go. Sorry about that. The Zoom UI took away my mute button. Yes, so thank you very much, Chris. And yeah, I think the point there is that we're showing kind of just a handful of tests in this example. You guys are going to have hundreds and thousands of different tests that you need to be able to optimize in that process. Okay, so now I can't advance the slide. Here we go. Okay, so we touched on a few things. So Chris showed us the AI-powered recommendations. And this is really a plugin right into your existing Selenium tests. So you just plug right in there when we detect a failure in your test execution, be it as part of the CI process or be it locally within your own IDE, we're able to identify how you can fix and repair those. And this is where the AI and machine learning of Parasoft Selenic comes in. It's learning from history. It's learning how the application is constructed. It's learning how the application has been tested historically. That same learning can be applied at runtime to reduce the failures of your CI/CD process. Anybody that knows or has done a test automation at any level of scale knows that there's always a certain amount of instability in your test automation. What you want to do is to minimize that as much as possible and streamline the process of remediating and addressing those issues. And self-healing really helps reduce that, with AI helping you, or the recommendations helping you kind of reduce the amount of time that it takes to actually fix it in the first place. Then we have reporting and traceability. Not just reporting on the pass-fail information associated with the tests, but being able to report on the internal details of why the tests are failing, putting that into context, providing screenshots, but then also providing the performance benchmarking that Chris showed us. This really is a very powerful way of getting an early warning on potential performance issues that have been introduced into the application. Many times you won't identify those performance issues until you do your load and performance testing at the end of your release cycle. And this gives you an early warning to the right at the beginning of the process. And likewise, through the use of traceability, we can really hone in and focus the quality feedback to specific user stories and business requirements, so you understand what the impact of test failures are within the functionality of the application. Simplified test creation. This is really making the creation of Selenium tests much easier. You saw Chris being able to interactively just, in essence, record his interactions, and then it creates Java code at the end of it. Now, there are a lot of different tools out there for doing quote unquote record and playback. None of them are perfect. What you need is something that can get you going and gives you a completely open box so you can go in and make changes as needed. And that's the key thing with the Java-based unit tests, or sorry, Java-based Selenium tests that Selenic is creating in the IDE there. No vendor lock, pure Java code, pure Selenium. You can go in and tweak it, and it really gives you a jump start with that page object model to make sure that you can actually kind of accelerate forward. And then last but not least, smart test execution. How can I execute my tests in a smart way? And by focusing on the change, that means that I can get quicker feedback as part of my CI/CD process. It doesn't mean to say I'm going to eliminate the execution of a complete test suite. But what you want to do is you want to get as quick a feedback as possible. And then, yeah, you're going to run your full automation suite, but that might take overnight to run, or at least a couple of hours. So what you want to do is you want to get quick feedback in minutes rather than hours as part of that test execution process. Now, I mentioned earlier, obviously, the testing pyramid. I also mentioned a couple of other products from Parasoft set. So we talked about unit testing, and I mentioned Parasoft JTest. The kind of things that you're seeing here with Selenic, we do similar things with JTest and for JUnit. Analyzing your Java code, helping you create your unit tests, helping to increase code coverage within the underlying code base, and really making it easier to establish that foundation of unit tests built on top of secure and reliable code. So JTest has deep code analysis going beyond a Sonar Cube or open source tooling to really uncover those hidden reliability and security issues within the application. Moving up the pyramid, we start talking about API testing. Chris kind of touched upon SOA tests very lightly today. Please stay tuned for upcoming webinars from Parasoft. We actually will be talking about API testing in a few weeks. So kind of look out for emails from Parasoft announcing that. Parasoft SOA test gives me the ability to not just create individual atomic API calls. You can chain them together into data-driven test scenarios. You can do that very seamlessly by analyzing your OpenAPI or your Swagger document, as well as analyzing the behavior of the application as it's being exercised. So we can capture the API calls that your front-end UI is leveraging, and we can stitch them together with its AI and machine learning to identify patterns within the underlying API traffic. I mentioned this earlier. I said this is really a sweet spot for where it comes with load and performance testing. I did see a question come through around performance testing of Selenium, and I'll touch upon that in our Q&A section as well. So please feel free to go add more questions into the Q&A. I see there's a whole bunch coming through, so that's great. And then obviously the focus of today's conversation has been Parasoft Selenic. Now, when I'm talking about load and performance testing, though, sorry to just step back for a second, but when I'm talking about load and performance testing, one of the challenges that many people face is the actual test environment itself. And this is where a concept called service virtualization comes in. Service virtualization allows me to simulate my back-end dependencies so I can decouple my test environment from constrained infrastructure, other services that I may not have access to. Parasoft Virtualize is our enterprise-grade solution for organizations to be able to set up virtual test environments. There is actually also a community edition version of Parasoft Virtualize available for free for individuals to use within your own local environment as well. And then, as I said, Parasoft Selenic has been kind of the primary focus of today's conversation. Now, if you're interested in getting access to Parasoft Selenic, there is a free trial available. You can go to the website. You can also email our team directly. They can help you get set up. And there's a whole bunch of additional videos and information available both through YouTube as well as through the Parasoft blog as well. And that YouTube channel is very rich and very deep. In fact, we're going to touch upon some of these questions here and actually reference some of the YouTube stuff, because one of the first questions, Chris, I'm going to just throw this at you while I look at the questions that have just come flying in now. One of the first questions, in fact, there's like been 3 or 4 around TestNG, so I'm going to throw these all together. Can you talk about TestNG versus JUnit and kind of talk about what we do from a support perspective for those 2 frameworks?
Absolutely. And now I see why you referenced the YouTube channel. So everything that you saw today was in Java. We were using JUnit 4 and 5 as we were executing. But for us, it doesn't really matter what Java-based code we're executing, whether it's TestNG or whether it's JUnit. In the Selenic video set here in YouTube, one of the videos that we have is how to use TestNG with Parasoft Selenic. So for us, it's more about you have a framework that you're executing in, and you want to reduce the maintenance for it. And so Parasoft Selenic integrates with what you're doing, whether it's Eclipse with JUnit or whether it's IntelliJ today using TestNG. We support those.
Yeah. And I would say that we support both JUnit 4 and JUnit 5. One of the questions was around, is JUnit TestNG better than JUnit? I would say that TestNG is definitely better than JUnit 4. JUnit 5, though, is really addressed a lot of the shortcomings of JUnit 4. JUnit 4 was a really good unit testing framework, not as strong from the point of view of more of an integration or functional testing framework, and JUnit 5 addressed a lot of those issues. We typically recommend JUnit 5 just because it is kind of really, it is more feature rich than TestNG. However, as Chris mentioned, we do support both JUnit 4, 5, and TestNG as well with Parasoft Selenic. Today, what you'll actually notice is on the Parasoft forums, you will actually notice a Selenic section, and under that is the roadmap for Parasoft Selenic. You'll notice on there that support for creation of TestNG scripts is going to be coming in our next release later this year. So all of the AI recommendations and the self-healing, the reporting that Chris was showing, all of that's fully supported with the TestNG. Creation is supported for JUnit 4 and 5 today, TestNG coming later this year. As another question here, which we should have probably mentioned this earlier, is like, what about support for Eclipse? I guess this is the one time when we don't do the demo in Eclipse that we get the request for Eclipse, yeah?
Yeah.
So in fact, actually, if you look on the YouTube channel, you'll see pretty much all of those videos are actually done with Eclipse. We saw that a lot of folks today, pre to this webinar, were IntelliJ folks, which is why we kind of focused on IntelliJ in this session. Okay, so then we have and I've had this question a couple of different ways. I had a question about JavaScript. I've had a question around C#. So I'm going to kind of recategorize this question as what about non-Java Selenium tests? So yes, Parasoft Selenic today supports Java-based Selenium tests. And we just got one about Cucumber. Yes, we support Cucumber as part of that, obviously if it's built on top of a Java-based Selenium test. We do have C#, Python, and JavaScript kind of on the roadmap. So if you guys are using something that is not a Java framework for Selenium, can you just type that into the chat and just kind of throw it in there, and then kind of that'll be useful for us from an ongoing kind of product management perspective. So those guys, C#, JavaScript, and Python, not necessarily that order. We're currently assessing which one we want to tackle first. Those are going to be the primary ones that we're going to focus on next. That'll be again around kind of the same stories such as the self-healing and the recommendations, because certainly that is the primary challenging one. For folks that are using C#, if you could also fire in which IDE you are using. I'm going to presume it's Visual Studio, but that would be, if it's VS Code or something like that, that would be also interesting for us to know as well. Okay, we had the Cucumber question. This one's kind of related. So what about keyword-driven frameworks? I know, because you've been doing a bunch of stuff with keyword-driven frameworks recently. So do you want to take that one?
Right, and I think this is, I saw this come in as dynamically constructed XPaths, and to me that always makes me think of keyword-driven frameworks, is this idea that in your code you're not explicitly defining what the element locator is. It's referenced somewhere else, or it's built somewhere else. And so yes, we fully support that. In fact, one of our customers for Selenic is purely driving it from a keyword-driven frameworks. And the way that it works is that the keyword-driven framework defines, what is the data, what is the element locator, and what is the action that I want to perform. And then that is then constructed inside of the Selenium code. That Selenium code then makes the call to WebDriver to do something in the browser. We don't care about what happens previously to construct all that together. We see it once it's fully constructed. And so if there's something wrong with it, or if there's something wrong with the element's weight condition or something at runtime, we then come back and say, this is what you put together, and this is why it didn't work. And we either self-heal that or provide a recommendation for how to make that more stable, and exactly where in the code that takes place. So, so yes, we support keyword-driven frameworks.
Okay, great. Thank you, Chris. And you're giving me a bit of time to try and read some of these other questions. So, the one question here is, what about performance testing of Selenium? Do you want to take that one, and then I'll
Sure.
kind of add to it as I see.
Sure. So there's many ways that we enable performance testing to occur earlier and with less resources using Parasoft Selenic and Parasoft tooling in general. The first thing that you saw, and I'll actually just click on it right here, is when I was recording that test, I had the ability to simultaneously grab the API traffic. This is good for a couple of different reasons. One, it really helps you understand what APIs are being used as you're interacting with your UIs. But you can also take those APIs and load them into your performance or our performance testing tool, Parasoft Load Test, and then execute at the API level, which is much easier to control for your performance test. At the same time, we do have the ability to execute those Selenium tests as a part of the performance test. You can either execute a pure UI-driven, a pure API-driven, or combine them together for hybrid analysis, where you put the majority of the load on the system using the APIs, and then use your UIs to validate the system. All of that is completely possible with the solution. And Mark,
Thank
I
you,
think
Chris.
we might be getting up against the time, but there are a lot of questions here.
Yeah, I think we'll just take one more question. I just saw one that I was kind of interested in. Now I've just lost it. Okay, yeah, actually, it was talking about the AI and how that works. So the question is, you know, are we uploading the in essence the web content to the Parasoft server for analysis? Actually, the content or the AI machine learning is all done on premise in your own infrastructure. So we're actually capturing information about the pages, and then we're analyzing those, but we're storing the model all within your own environment. So it's not a cloud-based model, because we know, you know, we have a lot of clients in financial industries, and that's typically very sensitive about sharing content about web pages and things like that. So we've designed it so it all works on premise or on machines that you manage, should I say. So it can be deployed obviously as part of an AWS or Azure cloud infrastructure, but it's on machines that you're managing and as a part of your network. Okay, so with that being said, I think that, you know, we have just gone a little bit over. There are other questions, so we will respond offline on those questions. So thank you very much for the time today. Please stay tuned for emails from Parasoft announcing other webinars that we're running. So we're going to go into API testing. We're going to go into performance testing in the future as well. So you'll hear another one of those coming up. And yes, the slides and the recording will be available and shared after today's session. So thank you again, everybody, for your time today. Really appreciate it. Feel free to reach out. Chris, thank you very much. And everybody else, have a great day.